Welcome, everybody. This is session 4. We're going to continue with Neil's work from this morning. We're going to give it a few minutes, let everybody get back in. We've only got a few of us in here at the moment. So just hang tight and we'll give it about another 5 minutes and then we'll get started. Neil, did you want to answer? Paul just had a question. He says, is the GitHub discussion section the best place to reach out for help in the future? Do we have another method for people to contact us?
That is a really good question. GitHub, if you have issues, yes. Issues about the agent. I've used it for other stuff, like just in general understanding or something like that. But if you need help and you want to talk about something, we used to have the MTConnect AMT email that it used to go into and get dispersed. But that's a good question. I don't know if who's manning that right now. We got to make sure that somebody's getting those emails.
Paul, just to give you a little bit of an answer on that, we're going to have a wrap-up meeting tomorrow. The 6 of us that have been involved in presenting, and Alyssa, our assistant from AMT side, we're going to wrap all this up. We are going to have like PDF versions of the slide decks available. And what will probably happen right now is we will send out emails to the people that registered and were attending each session with the slide decks from each session and make that available to everybody. And then amongst the group of us, we're going to talk about how do we give you guys access for the future for questions and things along that line. So we'll be addressing that with the Education Working Group going forward, since this is our very first training session we've done like this. So we're gonna follow all that up and probably get some emails out to everyone next week as to where they can find the resources and how we can help moving forward, because that's the kind of feedback we really want from everyone as to what resources would you like and how can we support that between the MTConnect.org group and the AMT side as well. So stay tuned. You'll be getting emails. Whatever email you use to register, that's the email that's gonna get sent the information. And Will just commented that if you join the SC or the standards committee, and if you sign up and join the standards committee, which is free, and stay current issues from each working group as to what we're adding and how we're adding it. You'll have input, have the ability to have input in there. We would really like more involvement, especially from end users and some of the OEM partners, because a lot of us are, as in my case, I work for a integrator / supplier of software, and we have a lot of other members that are in the same situation. We really want more end users and telling us what they want the standard to include so that we can grow the standard to meet your needs. Without that input, we're using our own experience and our own feedback from customers that we're dealing with every day to tell us what to put in the standard, but we'd like some more end user or consumer type feedback as to what the standard should contain and how we should handle it. So good. We're getting about, let's see, we got about 40, 50 people in the group at the moment. So I'm going to turn it back over to Neil and let him continue with where we left off this morning.
Thanks, Mike. All right, let me shut my camera off. Okay, so this morning we talked about device files. This afternoon we're going to talk about how to query agents for that data that we configured. As Mike just said, benefits to joining the Institute, a lot of contacts, get involved in discussions and issues. So session 4, querying agents for data. We're going to learn how to query the agents, why we query them, and maybe some different use cases and scenarios. What are the best methods for specific situations? So you're going to see, and as we go along, I'll give you some examples, but there's a few different ways of querying the agent. And in some cases, no big deal, no harm, no foul. You can do it a certain way. In other cases, you probably shouldn't do it that way. So there's really best practices that we want to encourage, and we'll cover that. So again, 30,000-foot view. We got our agent. We're getting data from adapters. This morning we talked about the device models in part 2. We're going to talk now about part 3 and part 4, basically streaming data back from the agent. We're going to talk about doing current commands and sample commands, and actually doing them in conjunction, using them together for solutions. Okay. This is the area we're talking about. So if you're looking at some sort of pipeline, we're looking at, data's coming in from all different machines, different adapters. Agent gets it, right? Maps it to the device file. Now you've got normalized data. You have MTConnect vocabulary coming out of the agent. How do I get it? So we're talking about querying those agents to get the data and do something with it. Now, certainly, I would say a bunch of people are going to want to have some sort of collection, right? They're going to want to collect this data. Maybe you have a collector engine running a piece of software that's going to collect data from all the agents in your facility and push that data to a database. Now you have a nice, clean, normalized database for the analytics or business applications, whatever you're going to do. The other way might be a simple dashboard. Now, you may not want to go to the database to get your data for a dashboard. Maybe you're doing going directly to the agents and getting a simple update, right? Maybe you're only polling doing a current command every 10 seconds. It doesn't need to be real time or anywhere near real time because it's just a dashboard that, hey, it's not mission critical. It's just showing status of the machine, and 4 seconds is plenty accurate, right? So you could definitely do that. You might not want to have 20 live dashboards or more all hitting those agents at 2 seconds or 1 second, right? Because now you got 100 polls per second, right? So you got to keep in mind what the scale is, how big you're going to go. The concept of having a clean database is really important because this whole idea of MTConnect, or having a data model coming out of here, the edge, which I call this the edge, right? Now there's a logical edge and a physical edge. I call this my logical edge. When you're talking to the agents, I'm getting data. It's clean. It's all the same language for all the machines. This is my edge. This is where, everything begins for data collection for the enterprise. Everything to the left of that, it's ugly, right? Anybody who's done machine connectivity, all the machines are different. We've talked about this already. And it doesn't matter how you get the data, as long as you get it and you normalize it to MTConnect. Now everything's clean. The difference with the way we're doing it today is that, in the past, we used to just take data from the factory floor, push it up into the cloud or a database, and you had this huge database in the cloud, a data lake with unnormalized data. And the data scientists spent 80% of their time, trying to normalize the data and figure out what it is. And they're not domain experts. They know nothing about industry or the factory floors. They just want to take the data and do equations and, pattern recognition or whatever. So today what we do is the domain experts, the factory automation folks, the people connecting them and writing adapters that know that specific product or whatever, they're the ones that are normalizing the data. They're the ones that are pushing information out and, developing the device files, hopefully, and saying, here's the context and here's how it is. This way here, upstairs now, it's nice and clean. You don't have to worry about any of that mess. Let the people who know what the context is, the domain experts, deal with it. So this red box is what we're dealing with today in this session, and we're going to move forward. So problems that we have today, and we touched on this a little bit in the morning, is client applications are getting more data than they need. If you've ever done database querying, you have the where clause, right? Don't say select asterisk and just get everything in the database. You want to say select these 3 columns, only the pieces of data that I want, and only where the timestamp is greater than yesterday, or midnight or whatever. You want to limit the amount of data that you get, nothing more than what you actually need, because otherwise you're looking at overhead in the network. You're looking at CPU and RAM overhead. You got to be careful. The other one is client applications getting data faster or at sample rates than they need. And we discussed this before, where you can filter and you can reduce the amount of data that's going through. You can use discrete on or off or filter duplicates, right? You want to make sure that that stuff isn't happening, and that's mainly the place to control it. And then the other thing that people do is they poll for data rather than streaming it. So can you imagine having all those dashboards, like I said, and you say, hey, I got 20 dashboards all hitting this, or 100 dashboards hitting these agents 1 time per second. That's 100 polls per second per agent. That's a lot of overhead that you don't need. And when you're doing a current, you get the whole stream or device data back, right? You get every single value for every single tag, and we don't always need to do that. So it's basically denial of service. You're banging the heck out of an agent. If you have a data collector or any type of client app, and you're polling, and that's your main method of getting data is polling, you're making a mistake, and you shouldn't be doing it that way. You should not be using current to get all your data and put it in a database or store it or do whatever. If it's a simple dashboard and you're polling once every 10 seconds, you only have 1 or 2 of those dashboards, no harm, no foul. It's not going to hurt anything. But it doesn't scale, and you shouldn't be doing that way. In addition, when you do current commands and you poll every 10 seconds, what about all the events and data that changed between them? So now you're missing data. So if you're archiving your data and your plan is to put this in a database, or you're going to, you're a client software and you're grabbing the data and you're putting it in a database, if you're polling, you're missing data. I can almost guarantee you're missing data. So some of them actually figure that out and they say, hey, we're missing data. We're not getting all the data. Okay, let's poll faster. And they start polling every 100 milliseconds or something. You are banging the heck out of the agent. You shouldn't be doing that. Other apps might be trying to connect to the agent, and depending on what your resources are, you could have a problem. So these are things that we want to make sure that we avoid. They're easy to avoid, but they're very, very often abused. So we need to talk about that. Okay, querying the standard buffer. So we've been doing this morning with a current command. We're going to talk about doing with now a sample command, and we're going to show you, we're going to reiterate to you right now in a demo how the buffer works. Okay, so what I'm going to do is I'm going to load the agent buffer 1 observation at a time using the demo adapter. Then we're going to view that buffer using a current. We're using it as a sample as well. And then we're going to watch the numbers increase until the buffer overloads, and you actually see the sequence numbers go outside the buffer. And this is going to be really important because you're going to be needing these values as we move forward in querying. Okay, so I have everything there, all that's running. I'm going to start my agent. My agent's running on the other screen. I'm going to start my adapter. It's running here. I'm going to open up my browser, hit refresh, localhost. Let's clean this up. Sample. Okay, gotta have a count in there, don't I? Keep forgetting. I gotta have a count because my buffer's so small. Okay. So when I come in here and I do a sample command, I didn't put any data into this adapter yet. But you'll notice that in the buffer, it's going to say buffer size is 16. Where does that come from? That's pretty small. I'm going to go look at my agent config file. And you're going to see buffer size equals 4. So that's 2 to the 4th power. 2 times 2 times 2 times 2. Gives me 16. So when you put in a value of 16 or 17 in here, 17 is the max, you put a value in there, you get 131,072 sequences that can be pieces of data that can be in that buffer. So it can get pretty big. That could be anywhere from 8 hours to 2 days or 3 days worth of data, depending on how much data and the frequency and so on. So the buffer size isn't a time as much as it is how many events or observations that are in there.
Neil, so any recommendations on buffer size or what it should be? Because I know in my experience, when you get a config from a vendor, that some of them just default to the largest, was it 16 or 17? And some of them, they're all over the map. Is there any guidance on that?
No, I think it would just be experience. If you don't have a resource problem, 17 is not a problem. You start getting into a situation where you're running the agent on a Raspberry Pi maybe, and you got other stuff running on there, and you're limited with CPU or whatever. Reduce it, because that agent has to manage that first in, first out buffer. So cut it in half, and you might see the memory usage go down, and you'll see the the RAM go down. You'll see the CPU go down for sure.
So that may be important if you've got an adapter and agent that's on the CNC control. The buffer size may actually have an impact on the CNC machine itself, correct?
Yep. And if they're doing real clean events and they're not like sending high frequency data and stuff, a smaller buffer works just fine. If you have a lot of what people refer to as digital exhaust, right? You got all those extra pieces of data that haven't been filtered out, and you're getting more data than you need. That data is going into the buffer. I've come in on a Monday morning and looked at an agent, looked at the data in the buffer, and it was all like load, I said, from that machine. The machine just sitting idle, and it's just the values just jumping up and down. If you can quiet that all down, you can definitely reduce the size of your buffer for sure. Okay. So we got it set to 16. Buffer size is 16 pieces of data. And if you look, it says first sequence 1, last sequence 12. And next sequence is 11. So that's interesting. Well, how do I have that much data in there? If you look in here, everything is in here unavailable, right? When the agent started up, unavailable is a value. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, let's see, there's more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Missing something, but it's there. Okay, so we've got 1 through 12. So we got 12 pieces of data in there. Of course, I counted to 10. Let's do this, 16. There they are. Okay, so I get the rest of them. So this is actually increased right now, and I should do this. Purpose of my demo. Shot myself in my own foot by adding all those tags in the last session. So let's just remove a few of these, this coolant. File. Save. Start the agent again. And I'm going to hit refresh. Okay. So here we are. The buffer size is 16. I'm telling it to return 16 in the sample. So I'm getting everything in the buffer. And you see the first sequence says 1, last sequence says 10. And it's because I have 10 pieces of data in here. The agent starts up, sets them all to unavailable. So I'm going to come in here. I'm going to grab this avail, copy. I'm going to set avail equal to available. And when I do that, you're going to see buffer size doesn't change, but you're going to see first sequence is still number 1. It hasn't filled the buffer yet, but this is going to turn to 11. And next sequence is going to turn to 12. It says the next piece of data you put in there, we'll give it a 12. So I refresh, and you see now I have 11 pieces of data in there. Execution. Active. Refresh. Now I have 12 pieces of data. Okay. Can't have duplicates, so it won't let them go in. I hit ready. It's going to be 13. It's 13 now. Okay. So let's get right up to 16. Fresh. It's 14. The next one is 15. And if you look here, look at, I got 1, 2, 3, 4 execution. It started out as unavailable. Set it to active, set it to ready, set it to stopped. And if you look at the sequence numbers, 12, 13, and 14, right? That's the last piece of data in there. It's going to be 15, 16. Okay, so the first piece of data in there is number 1. The last is 16. That's the size of my buffer. And the next says it's going to be 17. So when I come in here and I do this, and I change it again to whatever, what's going to happen here is now the first sequence is going to be 2, because 1's going to fall out the side of the tube, right outside, first in, first out. That first piece of data, the oldest piece of data, fell out. It was probably one of these unavailables, okay, one of these other tags. So basically, I'm missing a tag right now. Why? Buffer size is 16, it's full, it's gone past, it fell out. I should have looked to see what 1 was, okay, but look at here's sequence number 2. It's controller mode. When I enter another piece of data, I'm going to lose controller mode. It will not be in the buffer anymore. So I'm going to come over here, I'm going to do something again. And you're going to see this 2 go away, and I won't have controller mode anymore. Controller mode got pushed outside the buffer. And you say, well, wait a minute, now I don't know what controller mode is? No, this is sample. This is in the buffer. If I go do a current, I'm going to see it. Because current always hangs on to the last known value for every tag. Controller mode is right here. Oops, controller mode. Okay, and it was set, it was unavailable, so it stayed unavailable. But that's the last known value. Last known value availability is available. Last known value of execution is ready. That's what I put in here. So current is always the last known value from time the agent started up, and whatever you set it, they could have been yesterday. It got a timestamp. It's no longer in the buffer, but you'll see it right here, and it said, hey, at 11 on 11/5 at 18:48 UTC 09, that controller mode was set. So I actually, we'll leave them nameless, but I actually know a vendor that assumed that these tags were always still in the buffer, and they were using sample to try and find it. And when the tag went out, they were looking for it, and they said, oh, it's not there. We got no value. Something's wrong. And that's not the case. You do a current, and you'll know what that last timestamp was when it last changed, whether it was 5 minutes ago or 2 days ago. You'll always know that, unless the agent restarts and you don't get that tag from the adapter. Okay, so this is how the buffer semantics work. You have a buffer size. You have what's the oldest piece of data? What's the last piece of data put in there? And then what's the next piece of data that hasn't entered the buffer yet? What's that sequence number going to be? And we're going to use these to navigate. These are your pointers. This allows you to navigate the buffer. You don't use them so much to navigate and go in there and grab certain things. It's very unique situations where you might want to do it. I would say in more than 95% of the time, you don't need to go in there and find a specific one, but there's some cool scenarios why you might want to in use cases, okay? But this definitely affects how we stream data, and we need to use these.
So Neil, just to recap, if you were to restart the agent, then the buffer gets cleared and you'll go back to 1, but your instance ID will change, correct?
Right. Exactly. So instance ID, we talked about that yesterday. There it is. It's 489. Okay. And this is basically a timestamp that's been turned into a long integer, right? So this instance ID is basically a timestamp when the agent started. So look, it's 8489. I'm going to stop the agent. I'm going to restart it. It's on the other screen. It started up. And when I hit refresh here, watch what happens. Buffer size is 16. It's saying first one in there, the oldest piece of data is sequence number 1. The last one is 10, right? Because the agent started up and it put 10 pieces of data in there, all 10 tags, all unavailable. And the instance ID is new.
So one little note from an applications standpoint, since that's where I live in, is if you've got a problem with agents that are stopping and starting when you're monitoring data and you've got it all set up for the customer and everything's recording, and you get agents that are constantly stopping and starting due to computer problems, server issues, network issues, or whatever, you can look at that instance ID and know that, if the agent's still running and it's on a VM and it's running quietly in the background, that instance ID should stay the same for days or weeks on end until somebody reboots something. But if that instance ID's changed, you know that things are stopping and starting. And if it's a new instance ID every morning or 3 times a day, you've got a problem with the adapter, with the agent constantly starting and stopping on you.
Right. Good point. Okay. So we overloaded the buffer. We watched the sequence numbers change. Now you understand that. What I'm going to do is I'm going to do a simple query. And yes. I'm gonna go here. Thank you, Mazak, for having agents online for us for today's demo. So I'm doing a current statement. You guys know how to do current. And just to beat a dead horse, a current gives you last known value, every last known value of every tag, unless we use XPath, which I'll show you how to do. It's like a where clause. You can say where this equals that or this equals that. But right now, when I do a current with no parameters, I'm getting everything. Here's all the data tags that are running on this agent for that machine at Mazak right now. Okay. So what I want to do is, and I'm going to share this with you, is give you some sample Python scripts. So I've got some sample scripts here. The first one is polling an agent using Python. Okay, and so this is good. This will be an example for you. And basically, I'm using the same URL I just typed in. It's going to this Mazak agent running on 5611. I'm doing a current, and it sleeps for 5 seconds, and it polls again. So I'm going to run it, and you're going to see the data coming back. Okay, count to 5, and you're going to see the screen flicker. It just flickered. This is a low frequency polling. Am I missing data? Yes, there could be events. I guarantee you there's events like feed rate, loads, and things like that, position data that's changing. And if you don't need, if it's just for a simple dashboard, or maybe your diagnostics, right? You have a diagnostics tool of some sort, and you just want to scan and check for information, that's fine. It's 5 seconds is not going to hurt anything unless you got a bunch of dashboards doing this. You don't want to have all of these things all around the factory hitting agents, okay? That is a simple loop polling. We talked about something else yesterday, and of course I want to close this. Very distracting. I want to come here, and I'm doing a current command, and this is XML. We talked about how agents do JSON. There are plugins for browsers. I think Trace brought it up yesterday. I like this one here, this mod header one. I put in accepts, and then you put the as a header, application JSON. I can enable it, and then I can hit refresh, and you'll see I get an error. Should get an error. Or it doesn't give me an error at all. It's just going to give me a whammy. It's not going to reply anything. The reason why is that version agent didn't support JSON. So if I go to 57, T719, which is one of their newer agents that's running up there, you'll see I get JSON back. Here's the header, here's the streams, and you can just keep opening it up, and you get JSON. Okay, so I can disable that. With a browser, you can, if you want to see JSON, you can do JSON. Just make sure you reset it before you go to other websites, otherwise it doesn't like it. I have a script that does that as well. So if I come in here and I look at this, you see I'm going to that same one, 5719. It's a later version agent, supports JSON, and you see it puts a header in there before it makes its HTTP call, application JSON. And when I run this, you're going to see JSON formatted data. Okay, and every 5 seconds, it's given me JSON. Again, this is polling every 5 seconds with a current command. Not something you should be doing all the time. Okay, inefficient. All right. So let's talk about that buffer. So pictures are worth 1,000 words. Here's my buffer. Let's assume that it's 1,000 sequences. The buffer size is 1,000, okay? Probably won't ever be, but let's say it's 1,000, just for roundabout numbers. Data comes in, right? You got first sequence is number 1 until it fills up, until you get to the point where you're right here. First sequence is 1, the buffer's full, last sequence is 1,000, next sequence is going to be 1,001, right? So this is the oldest data in the buffer, and that's number 1. When you do a sample command, like I did before and I showed you sample, what happens? Go back to my browser. And I'm going to do a sample on that 5719. If you look, I get a bunch of data and you say, yep, that looks like the buffer. I see a bunch of duplicate tags in there. It's got all the tags I want. Specifically, there are 100 data items in here, 100 observations, 100 sequence numbers, only 100. If I look up at the top at the buffer size, 4,096. This is not 4,096. So what am I getting? I'm getting 100 lines of data. Specifically, you're getting the oldest 100 pieces of data in the buffer. I had a client application, this is years ago, where they were polling the machine. They said, we're changing the machine. We don't see it changing. They were polling, instead of with a current to see the latest value, they were using sample. And they were getting the oldest 100 pieces of data in the buffer. And of course, they look for execution, and it was old, very, very old. So when you do a sample with no parameters, I won't say it's useless, but you're only getting the oldest pieces of data in the buffer, and it really in only 100. So the default return for either a current or sample is going to be 100 pieces of data. If you have a device file that has 150 pieces of data and you say current, you're not going to get all 100. Okay, you got to make sure that you use a count. So actually, for sample only, you won't get all the data in the buffer. So if I come over here and I were to say sample from 900, so I'm using this first time we use parameters. I'm going to say from 900. I will get 901 through 1000 at that split second before new data gets put in there. I'll always get just 100 pieces of data. It's the same thing as saying from 900, give me a count of 100. Okay, so if I come back to my browser and I say sample, and let's do a from, what's the last sequence? So the next sequence is going to be this. Okay, copy. Let me refresh first with this current. Let's do a current. Say current. Here's my latest and greatest. And it says the next sequence is going to be this. So I'm going to take that number and I'm going to come up here and I'm going to say sample question mark from that number, from equals that number. Okay. If you look, all I'm getting is 100 pieces of data, but it's the new pieces of data that came in since this, which means I got maintenance lists came in and got updated. Probably it gets updated every minute or something like that, or every 30 seconds. Whole bunch of path position. The machine must be moving so that the path is changing, and the timer is ticking away. So it was 10 seconds or so. That's probably like 10 seconds. If I hit refresh again, this is going to get bigger. What if I put a count on the end? I say count. I'm only getting 100 probably. So I hit count equals 1000 and I hit enter. Now I'm getting 1,000 pieces of data since this sequence, which means from the time I did that current, right now I'm getting everything past that. And it's filling up my screen here. You can see it's getting even bigger. Process timers, look at that. I'm getting all of this data. It's huge, up to 1,000. So this is what the from is used for, and count, and we're going to use it a bunch of times. You're saying from a specific sequence number, and if you don't add a count parameter here, it's going to default to 100. Now, if you're collecting data from an agent and you're storing it, there is a possibility that the agent overruns you, meaning that your pointers that you're using and you're chunking, you're coming back, let's say, every so often. Like I just hit a sample, right? I'm using a command. I'm not streaming here. I'm actually polling with a sample, and I'm saying, what did I miss? I'm going back and I'm saying, hey, I got this. Give me up to 1,000. There is a point where you're querying this agent, and your pointers of 100 are moving all the way back here to the next thing you know, the pointers you're using are gone because the data's coming into this buffer so fast. Okay, so sometimes I like to just go with 1,000, make sure I'm using more than I need. And if you do a current and then you come back and you say, you might come back 10 seconds later, you might come back 30 seconds later and say, here's the from that I want to use. Here's the last piece of data that I have. I need this one. Give me what I missed. Give me up to 1,000 pieces of data. Usually you'll get everything up to the end of the buffer. You might get 900 something lines or something like that. So using a increased count size is good. If you're going back, you come back with a sample command every few seconds, like every 5 seconds, and you say, what did I miss? You might be fine with 100. Okay, it really depends on how much data is going through. But keep in mind, that's the big point of this slide, is that you will get the oldest set of data using a sample by itself with no parameters.
So in other words, Neil, if you're using that type of a query and you don't have a from statement and you ask for 900 or 1,000, you're going to get the 1,000 that's there, and it's going to just pick up from what the first sequence was that's in the buffer. Is that what you're going to get back?
Yep, you're going to get the oldest piece of data. So if this keeps running, and like say that the first piece of data is sequence number 10,000, let's say, you're going to get 10,000 to 10,100. That's what you're going to get. You're always going to get the oldest data if you don't pass any parameters. And that's basically a useless query. It's not
right.
It's not okay, but you really should be using from and count, and we're going to talk about interval in a little bit to stream, but this is, the way the buffer works, and you want to avoid that. That's something kind of a gotcha that a lot of people do. And they said, well, I'm using a sample. I figured it would tell me, whatever, and I'm getting data back. It's not doing that logic for you. It's not saying, hey, only give him the change data. Unless you specifically say that. Okay. So you get first sequence, you get last sequence. When you do a probe, you get back your buffer. When you do you get back your device file. When you do a current, you're going to get over here. You're going to get the last known value of every single sequence or observation that went through the buffer, whether it's still in there or not. You will know those last values. Once you do a current, you're establishing a point in time. Now you can come back with a sample, and you can say, from 1001, give me a count of 100 or 1,000, and it's going to give you the new data that's going in there up to 100. Okay. We're going to talk about that, Drake, when what if I only want to get change data back. We'll definitely talk about that in a few minutes. Okay, so what I'm going to do is I'm going to do a sample command now with count. I'm going to load the buffer up and show it to you in a demo. I'm actually going to, let's see, yeah, we'll do that. Kind of already did, but we'll do it anyways. So we loaded up the buffer. I'm going to do a sample count with 5. And you see I get 5 pieces of data back, execution available, controller mode, emergency stop. You notice I'm not getting all of that other data. What am I getting? I am getting the oldest data that's in there. I keep pushing data in there. Okay, you're going to see this buffer fill up. I'm up to 15 right now, and you see I'm doing a sample with a count 5. Nothing has changed on here. I'm still getting the oldest 5 pieces of data, and the buffer hasn't overrun yet, so it's still the same pieces of data. As soon as I go over 16, I'm going to get back you're going to see this data change now because some of this is being pushed outside the buffer, and you're going to see some new ones. Okay, now I'm getting controller mode override. Okay, where am I in the buffer on here? Right now I'm getting, if I go look at my slide that we were just looking at, if this was my buffer right now, it's 16. I'm getting, oops, I'm getting from 1 over here, I'm getting the first 5 pieces of data that's in there. And every time new data comes in, I'm getting an extra 1 over here in the end. I'm just moved in. I just got controller mode that came in. So that buffer's sliding over, all that data's flying over, and I'm only getting those first 5 based on that query. Sample count 5. I'm getting the oldest 5 pieces of data in the buffer. Okay. All right. So let's talk about how you want to get this data, and you want to do it programmatically. First thing you're going to do is you're going to do a probe. Why? You want the metadata. You want the units of measurement. You want to know if you should expect a table, a data set, or a simple value. And the value is the default, right? So you do a probe, you get all the metadata. Now you should know, your data collector should know what to expect, what's coming in, and how to parse it. So you do a probe. Now you come and you say, I like to look at this as, logically like a loop, right? I do a probe, I get the metadata, but I also do instance IDs. I check instance ID everywhere I go. And if it changes, I immediately just fall out of the loop, go all the way back up and start over and do a probe because something changed. If the instance ID changed, your metadata probably changed. It's likely. Or it crashed, right? Your server went down, whatever. So you do a probe, you do a current, and then you're going to do a sample. And the sample is going to be from what? It's going to be the last or next sequence, right? You want the next sequence that's not in the buffer yet. So when I do a probe, metadata, I do a current, I get a snapshot, which is the latest data in the buffer of all the tags. And then I say, do a sample from there. So kind of did this already, but I'm going to go back to the AZAC machine here. So here's my probe. I get all of this data. I find out my types, what I'm getting. I find out unit of measurements, millimeters, okay? I find out everything that's in there. There's filters if you wanted to know what filters they were. Maybe there's some specifications in there, right? You want to know what the specs are. Whatever it is, you find out what it is. You can put that in your data collector. Now you've configured your data collector. Now I'm going to do a current. I'm going to get a snapshot of the most recent data for all the data tags. Here it is. I can populate variables in my software now with this, and this is my last known value. I can push that data to the database, right? I can push all those values with their timestamps because they're not going to be all the same. They changed at different times and when it went through the buffer. They may still be in the buffer, they may not be, but you're going to populate your database. This is a point in time right now. I got all of this data. I know from those timestamps, this is what the values were. You document first, last, and next sequence all the time. Every time you query the agent, you document that because now I want to go back with a sample command and I want to say from this last sequence. From that current, I want to come back to that with a from equals Control V. Count's going to be 100 by default. I'm going to hit enter. I just got back some data. If I do count, just to make sure I don't fill it up, count equals 1,000, 10,000, whatever. Too big. 4,000. Buffer's 4096, so I'll say 4,000. I might be getting back 1,000 here, might be getting back, I don't know, 2,000, whatever. But you see how big it is? I don't want to keep getting this data back again. So I did a sample command with that value and I got this back. I saved it all to the database. Now I'm going to grab this again, next sequence, copy, update that next sequence because I only want to get from this point forward. Go. And now look at, I only get a little bit of data back. It's just what's changed since I last visited. So this is what, 10 seconds it took me to go back since the last sample, and this is what I got back. And I'm only getting changed data, and I'm not missing any data. Everything is coming in from that point. I go back up to the top, grab the next sequence again, copy, put it in here, and you see it's doing it manually is kind of a pain, but if you're doing this programmatically, this is really simple to do. Boom, I got another one. You can see that these maintenance lists updated again. Okay, got a whole bunch of data that came in since I just did that. So this machine is obviously running because I'm getting tons of position data, tons of access feed rate, okay? Lots of position data in there. So the machine's running. If the machine wasn't running, you probably wouldn't see that much data coming in. But you can see just in that short amount of time, I'm saying 4,000. I'm not exactly sure how much this is, but this is a lot of data. It's more than 100, which means if I was querying 100, at some point it would overrun me. I would be out of the buffer. I wouldn't be getting the data. It's putting more data in the buffer than I'm collecting. So you got to make sure you're either moving fast enough or your count is big enough.
So Neil, from a use case standpoint, the reason to change all this or to have different utilizations would be the difference of Are you just trying to drive a dashboard to say whether you're running or whether you're stopped versus trying to drive a digital twin where you want to literally know every axis motion and every axis speed to be able to do a digital twin environment, correct?
Right. And this is not a bad way to collect the data as long as you're looping fast enough. Okay. It's still more efficient than using current because I don't have to poll every 10 milliseconds and still miss something by, possibly, right? I can come back every 10 seconds and I'm not missing any data as long as my count is big enough. I'm probably not going to miss any data and I'm getting everything, which is awesome. Why would you do this instead of streaming, which we're going to talk about next? I had a scenario where, like let's say you're using a scripting language, something that doesn't do multi-threaded. You can't have, you got one program that says, I'm going to go to every single agent and do a sample command, and I'm going to keep track of all of the sequence numbers for every single agent, right, in memory, which means you have one app that's saying, hey, give me what I missed. Go to the next agent. Hey, give me what I missed. And you're going like a round robin to all these machines. You come back to the first one, you say, okay, it might be 30 seconds later, it might be 2 minutes later. And you say, hey, what did I miss? That's basically what this method is. It's not a bad method if that's the way you have to do it. If you have a programming language where you're doing multi-threading and you have control of this, you could have one app that spools up a thread per machine, right, per agent that you need to collect, and they're grabbing the data like this, and it's not going to be a problem. You're not going to miss anything. It's not going to be the threads will be overhead, but there's different ways of doing it. This way here is more efficient than polling because you never miss data. You're always going to get it unless you let it overrun you, right? You got to make sure your count is pretty high. But streaming is the best, and we're going to talk about that, obviously. But you can see this is already better than, especially if you're collecting data. If you're a client app and you're collecting data, this is way, way more stable, lightweight, and you're guaranteed to get all the data. Whereas polling, I guarantee you're missing data. I mean, look how fast this came in 10 seconds.
Another comment on that too is what is your use environment that you're working on? If you're an end user and you're trying to figure out how to use MTConnect, or if you've got an integration company that you're working with, if you've got 4 machines in the building, which we have customers with 2-3 machines, and then we have customers with 400 machines in a facility. If you got 2 or 3, it's not a big deal. But when you suddenly try to grow this into 20, 50, 100, 200 machines, like Neil said, the overhead gets ridiculous, and suddenly you're going to start losing data, and you're not going to have really good data ending up in your application at the final use point.
Right. So first thing you do is a probe. Just to reiterate, beat a dead horse. You get the instance ID and maintain that to determine if the agent has restarted or something. You get any machine configuration. You can look at it and say, hey, how many paths, how many heads does this machine have? How many axis definitions do we have? You get the unit of measurements for your data items. You can save the data item IDs. We could talk about querying with data item IDs. They're a little more efficient, but I've never done it. I don't think you really need to use it, but it's possible to use that instead of the query names, the types. And you use the instance ID anytime the agent restarts. You say, oh, that's my trigger. I need to fall out and do a probe current and then sample again. Okay, so we do a current, establish a place and time, obtain the sequence numbers, right? First, last, and next. You can use this just to display on a dashboard if you want. If you want to just keep looping with a current, don't recommend it so much. Spend the time doing a sample. And then, of course, last thing you do is a sample with a from and a count. Get from a specific sequence number or index in the buffer. Count is like chunking. Make sure you give a big enough value. I think on all the data collections I actually did a test app that was monitoring a typical machine, and I was keeping track of the size of the buffer, how much data I was returning, and basically saying 100 wasn't enough to collect the data. Eventually, I'd get overrun. So I actually had it auto throttle, and it would change the count command up to like 150 and then maybe 200 or whatever. And I always ended up around 300. So I would say you go to count 500 or count 1,000, you probably will never have a problem. So if you look at this from a client app sitting here, you do a probe. What do you get back? You get back the device's XML file, so you have your metadata. You go in and do a current. You get back a streams document, right? You get back values, and you document all of your sequence numbers. Now you go back with a sample command. and you say from that next sequence, boom, you get back only change data. You grab that next sequence again, do a sample with that from, and what do you get back? Only the change data. And you just keep doing that, only the change data. And you're polling it, but only for change data. All right, let's start talking about streaming data. And yeah, I got a demo on there. So with streaming data, it's not any different. You still need to do the same thing. You're still going to need to say probe, do the same thing, unit of measurements, instance ID, blah, blah, blah. You're going to do a current. Same thing, establish a point in time. But now we're going to do a next sequence, and we're going to put an interval. We're not going to use a count, and you don't use them together. You're going to say ampersand interval 2000, so 2000 milliseconds, okay? Every 2 seconds, you're going to say, send me the delta, send me anything that I missed, send me only the new data, and I want you to push it to me. So the port stays open. Your data collector just sits there on that port, that TCP port, and the data just keeps coming to it. And either XML or JSON format, whatever you specified in the header, you're either going to get back data that changed, or you're going to get back an empty XML or JSON document that just says, no new data, but here's a heartbeat, right? I'm going to send you something every 2 seconds, even if there's no new tags. It's just going to give you the header, all right, and say nothing new. Interval is what triggers the agent and tells it to stream. And this is by far the most efficient way to get data from the agent. But every time you get a document back, you're going to have an instance ID in there that you need to check. If it stops, gets hung up, if it restarts, all of a sudden your collector's going to go, I'm on a port, I'm holding a socket open, and something just went whammy, and you're sitting there waiting, and it's going to do a timeout eventually, trying to do a ping and pong with the, trying to get data. It's going to hang up. But nonetheless, if you see the instance ID change, all of a sudden data starts coming through. You're going to go, oh, wait a minute, all my sequence numbers have been reset. Something's all janky. You got to make sure you restart, probe, current, sample, and get a clean set of sequence numbers. Okay. We're going to talk about shortly here about using XPath with this call too. And you can say, hey, I want you to stream to me only execution state and only controller mode and so on, whatever. But you can also use that XPath with the interval and such. But you essentially only are getting data when it changes. Okay. So if we look at that same scenario here, I do a probe, I get back the devices file, right? There's all my metadata. I do a current command, I get a point in time, I get back my streams document. So now I have a snapshot of all my tags at a certain point. Now, instead of going through and keep going back, I only send one command, sample from my next sequence number, interval of 2000, I want you to stream to me. And I send it, and what do I get back? Every 2 seconds, I get back a streams document, whether it has changes or not. Okay. You can't see this in a browser. Most browsers, or I don't know of any browser, modern day browser that does this. I believe it or not, if you're old enough to remember Netscape used to do it. It would leave a socket open. If you know how to do it with a browser to leave a socket open, that's great. If not, no big deal, because I have a sample. So I got this stream Python code, and it's going to, it starts out here, it goes to 5611, and it says interval 2000, just straight up, just says right from the get-go. I say sample. You notice there's no from in there. This is really important for this demo. I'm saying sample with a question mark interval. This will work. Is this correct? Depending on, as long as you know how this is functioning, you can parse the results coming through. But it's really important to understand what's happening here. What happens when you do a sample with no from? It always goes to the oldest data in the buffer. I'm saying interval 2000. I'm saying send me changes every 2 seconds. So what's going to happen here, and you're going to see it happen real fast. It's going to go to this address. It's going to go to the buffer, and it's going to say, give me everything. I want everything out of the buffer. It's going to send me, empty the entire buffer from the oldest data all the way up to the new data. It could be a day's worth of data, could be 2 days worth of data. It doesn't matter. And you're going to see it's streaming on the bottom of my window, my Visual Code window. It's returning all this data. Once it's done emptying the buffer and it's all caught up, you're going to get intervals of 2 seconds of either an empty document or just what's changed. Okay. And the cool thing about this is if you're starting up, you don't know what's in the buffer. You don't know how much data has changed or whatever. So rather than trying to poll it and figure it out, you could just say, hey, just give me everything. And I'm going to compare to, I know my timestamp of the last data that I have, let's say. Sequence numbers may have changed, but I know the last piece of data that I have by timestamp. And I'm just going to ignore everything before that timestamp. So you could do that as long as you know that that's what you're getting. So I'm going to go ahead and run this. And if you watch, it's going to happen really fast. It's going to flicker on the screen. You're going to see it streaming really fast, all the data, till the buffer's empty. And it did that pretty quick. And now if you look, every 2 seconds, it's sending me, look at axis feed rate, axis state, just 2 tags, 3 tags, 4 tags there, couple tags. Let me open this up a bit. It sent a bunch that time. So in 2 seconds, obviously the machine's running. This one here only sent 1. There's some more data changing. This is the most lightweight method, the most efficient way of streaming data out of the samples buffer or observations buffer using a sample with an interval command. Now, you might say, I don't want to do that. I don't want to send empty the whole buffer. The way you would do it is, like I showed you here, you would use the from command. After you do the current, you do from command and you put the interval on there, and then you'll only get, it won't go and empty the buffer. It'll just get from the current moving forward. Okay, that's it. This is my data collector. I'm collecting data from the agent. I'm parsing this small XML document. It's not that big. I'm grabbing the data, like 1 in that one. There was only 1 accumulated time. And I'm pushing it to a database. This is actually a significant amount of data. This is a good amount of data because the machine's running. Okay. Stop. Okay. We coming up on a break, Mike?
Yeah, if this is a good place to stop for a minute, this would be
Yep.
fine. We've been going for about almost an hour, so this will
Yep.
be great for taking our 5 or 10 minute bathroom coffee break, and we'll see you guys back at like 2:40 Eastern time, 1:40 Central time.
Like 13 minutes. Yep.
Yep.
Right.
Okay, welcome back, everybody. Hopefully Neil will be back shortly, and we'll be able to pick up where we left off.
I am back.
All right.
Okay. So before we jump into XPath, there's a couple things I thought of when I was sitting here. And that is, you've seen one way here with adapters, shutter. You've seen a second way to get data into the agent using MQTT. I could certainly have multiple adapters with shutter, like this, with a different IP address, same port, or maybe the same I could have 2 adapters running on a machine with 2 different ports, right? This could be 78, 79. And I could have shutter data coming in from these 2, plus MQTT data coming in through there. It doesn't matter, okay? You're getting data coming in, it's going to map it and so on. But there's another way that's not part of this adapters list that you can get data into the agent, and that's using HTTP. I can do HTTP put commands, and I can send data tags to the agent to update them. Now, obviously, you say, whoa, wait a minute, that's uncontrolled, that's a security issue, and so on. And if you see up here at the top, it says allow put, true or false. Allow put from who? Localhost or 10.234 dot whatever the IP address of the a particular device is that has an adapter running. You could have an adapter do an HTTP put commands. Okay, so I'm going to give you an example of that. Obviously, it's turned on in there. You've seen data coming in from this adapter that I have. You've seen data coming in through the broker. Another tool, test tool that I use for doing classes. You see I have agent IP is localhost, port 5000, device, which matches the device in the device file. It's called device. You could be machine one, it could be whatever. Execution tag, I want to set it to program completed. Okay, so I'm going to start my agent. Starting up on the other screen. Okay, the agent is running, connected to my two adapters. You see it right here, new connection and so on. Open up my browser, and I'm going to do a localhost refresh. Localhost, I do a refresh, and you're going to see execution right now is unavailable. I'm going to do an HTTP put. And if I come back here and refresh, program completed. So you can use Shutter, you can use MQTT and JSON payloads. You could also do HTTP put. This is a really unique solution for things like you have machines from a vendor. They have their own adapters and their agents running. If you can get to the agent, a config file, and set this up and put those parameters in there to allow, you can allow it to come from a workstation that's by the machines. Maybe it's a cell. And you have an adapter that, let's say if because it's a cell, you have 10 machines, and you want to go and set all of those machines to maintenance. You say they're no longer running production, they're running maintenance. There's a tag for this to designate an umbrella term that we use to say, what's the machine doing? And you could say it's running production, or it's in R&D, or it's in maintenance. So rather than having one adapter per machine, you could have one piece of code just like this app, and I could point to each agent individually in the background. I could have it configured in a file, and you could have maybe a button on the screen for each machine, and they're all green, and you say, click, I'm going to click it and say, I'm taking it offline. The machine is now in maintenance. And those could be used for setting downtime reasons if you wanted to do that. So there's some cool solutions for doing that where you don't have to change, you don't have to add an adapter configuration, but you just have to allow put. And you could have an app that's sending out, like a main console that's sending data to a group of machines, a cell, and you could push out, specific tags if you wanted to, like that. So anyways, HTTP put, there's examples in the Git, and I believe there's examples on the MTC Cup website as well for how to format that. You can use curl if you wanted to do it from the command line. So yeah. Okay. Didn't want to forget to share that. All right. So now you've learned to filter data, reduce the amount of data coming through. You've learned to collect metadata using a probe. You've learned to get a snapshot of the latest and greatest using current. You know how to navigate the buffer by using sample. You know how to stream using interval and get the latest, just the deltas. But when you're doing that and you're getting deltas, you're getting the deltas of every single type of tag. What we can do now is we can use XPath, and XPath is a standard. You can look it up. There's books on it. There's PDFs on it online, websites. You can get in there. There's different versions of it and so on. And this supports. I don't want to say the latest version, but there was 2 versions, and it was updated to support the later one at some point. I remember. So I've never run into a problem not supporting something I wanted to do. But if you look here, I have an IP address like localhost 5000 or whatever, current. And then you see question mark, and the first thing I'm going to pass as a parameter is path. And this path is basically the path in the device file down to the data item that I want to get. So you see // means, hey, from the controller section, go down the tree of that device file, that hierarchical device file. Go down that list in there, all those elements, until you get to a controller section. That's what the // means. You get to the controller section, then it says, hey, now look underneath it, find a components, find a path, and then find a data item section, and then find a data item where the @ type or the type is equal to execution. So which means only return the execution tag. So I'm going to try that. I'm going to collect this. I'm just going to copy this here. And I'm going to put this in a browser. And I'm going to use, of course, we're going to use the Mazak one again. Let's do this. We'll use the latest one, /current. Control V. And it's going to go find me the execution tag. So you saw how big that return was, that current was. I mean, look at now I just have one tag. So maybe I have a dashboard and I'm hitting that agent directly. And all I want to do is get one data tag. And I go back and check for that once every 5 seconds. And I'm just returning a real lightweight piece of data. And that's what I get. Maybe I want to say, hey, I don't want to come back and poll every 5 seconds. I'm going to use a sample command and do this. And that's exactly what will happen. Now, of course, you're going to want to use the from, but if I say sample without a from, I go like that, it's going to say what's in the buffer. There's absolutely no execution in the buffer right now. It didn't find any, which means it knows what the last current status was, but there's none in the buffer. But I could also use a current command, find my next sequence, and then do a sample from, and it'll only send data, every 2 seconds or an interval, right? And it will send you the data and tell you when just that tag changes. So look at 1759.13 was the last time it changed. And this buffer is 4096, so it's not that big. Okay, that's how you would get just execution. I'm going to take this, and because all of you are, just share that. So if you want to grab that, you can. What if I want to get execution and controller mode? Same thing. I'm going to grab this, and you see how it shows it? Grab the data item where the type equals execution or type is controller mode. So I'm going to go in here, do the same thing with a current command. Go to my browser. Place that, hit enter, and look, now I get 2 tags, execution, controller mode. That's a current status. So I'm doing a current, but I'm only saying, hey, only where execution controller mode is concerned. That's all I care about. You might want to put feed, maybe your overrides, rotary velocity override, right? The spindle override. You might want to do feed rate override, the rapid override. You can put all those in there, and you can make that a pretty elaborate query. So here we are. We did an example saying I want specific tags, but maybe I just want specific groups of tags. So I said, rather than making an elaborate X path that says, okay, get me path controller, blah, 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 data items with data item equals execution, controller mode, path feed rate override, rotary velocity override, program. Instead of doing all that, I say, hey, wait a minute, all that data is in the controller section. I could just say this. Just get me everything that's in the controller. So I can do that. Control B. Gives me all the tags that are in the controller section. Of course, the maintenance list is in there, which is pretty big. Work offsets table is in there. But you see, I got alarms, communications logic, blah, 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 path feed rate, cutting speed, orientation, path position, process timer, path feed rate override. So I got program feed rate override and rapid override. Those are subtypes, right? So I have path feed rate override. What's my program path feed rate override? And then what's my, my rapid. Look at my variables. 100 all the way through, blah, 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 9999. Okay, so I get 1,000 common variables in there. Execution state, active, what label in the program I'm at line 38. Automatic mode, program that it's running. Okay, so all of this information is just in the controller section, and I'm omitting all my access data. I'm not doing any of that other stuff. And it's just a simple, hey, get me what's in the controller. You remember what a sample gets you, right? Sample gets you all the oldest data. And if you guys want to try this, I'll put all of these in there. Sample count 10. This is going to get me the oldest 10 pieces of data in the buffer. And by the time I go back again, it's gone. Okay. Sample controller. It's going to say, get me the oldest pieces of data in the buffer that is in the controller section. Now, this is interesting because it's going to give you up to 100 pieces of data, but it's not the oldest pieces of data. It's saying, give me only the oldest pieces of data that are in the controller. So that's kind of cool. Go in the buffer and get me everything in the controller, but give me only a count of 10. So you're getting the 10 oldest pieces of data. Not very practical, not very useful there. Neither one of these. Current is kind of cool because if you just need to update a dashboard, you can just do a current with a filter and just get the data you want, update a dashboard. But only if you're doing a few. And then, of course, if you want to get access data, you say, only give me the access data. Now, this is kind of cool. We really haven't looked at examples of access data, but we will in a few minutes. Come on. I do. Only show me the access data. So here's my axes. Here's my rotary B, rotary C, x-axis, y-axis, z-axis. Okay. Any questions on using XPath? This is very simple. This is not a class on XPath. You can look up XPath and how to do it. Works pretty simple. The thing you need to understand, though, is that this is all being, if you say, hey, how do I create XPath? There's tools you can use like XML Spy or whatever, and you look at the device file. But essentially, you open up your device file. You open up your device file, and you start from the top. Devices, device, components, controller, data items. And you get all of them, or you can say where the data item is equal to controller mode. Okay, add controller mode. So you use your device file to create your XML, your XPath if you need to. You can't use a current or a sample return to create XPath. You got to use this architecture here, this hierarchy, to generate a path. I wonder if there's I should look to see if there's a plugin here for XPath to see if it would help me with in VS Code. There might be one where you can, I know in XML Spy, you can sit there and literally right click on it and you say generate XPath and it will, boom, it'll give you the proper XPath in the bottom down here. And you just copy and paste. But once you do a few of these, they're pretty easy to do and it returns just the data you want. Pretty powerful. Okay. Close this all. Okay, the next thing we're going to do is we're going to talk about querying assets. Assets are an entirely separate buffer. If you remember that picture I had up above with the agent, and you had the config file, the device file, the adapters, and so on. But in that agent, there was a series of, there was a buffer. Let's go back up here. Yeah. It's in the other slide. There was a buffer. So the agent has the streaming buffer, probe current sample. There's a second buffer that's there strictly for XML documents, and we call them assets, and they're live documents. It works like a first in, first out buffer, but they're basically live documents. So things like an XML document representing all of the tool data in the machine. We have an asset called cutting tool that has an archetype. We has a complete schema outlining the format of it and so on, that when you query an agent and instead of saying probe current or sample, you say assets, you'll get back information from that other buffer. So I'm going to go to a machine that I know has that, which is the Mazak machine here. It's 5719. I go there, there's my probe, current, right? Gives me a latest snapshot. Sample gives me, you know what? It gives me the buffer. If I come in here and say assets, boom, I'm getting back data from a separate buffer in the agent. Cutting tool, cutting tool, cutting tool. And if you look up here, it's going to say how many assets are in there. Asset count, 230 assets. That doesn't say 230 cutting tools, it says 230 assets. So what this means is there could be different types of assets in there. There's cutting tools, there's files, there's QIF for inspection data, inspection reports, so we can pass QIF documents, okay? You can do custom documents in here. I know a company that did a complete DNC package through the agent using the assets buffer. Every single line of a G-code program, they put an XML header, put it in wrapped it basically in XML. And once it got through and they got to the other side, they decoded it, stripped all the XML out, and they had their G-code program. So they were pushing data using put and going in here and querying assets to get the documents, and they were using it as a DNC system. And it was done securely because the agent was running on a gateway PC essentially in between the machines and the server network. So they could keep the machines isolated, and they were doing DNC down through the agent. Pretty cool solution. It was custom, but it worked because they were doing custom assets. So if I scroll down, let's see if there's anything else in there. There is. File. So there's a file type. So look at what type of file is it? It's a process type. What does that mean? It's a program, cutting program. Okay, it's a production program and has an ID. The asset ID has to be unique. And here's the program, th blah, 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 op3.eia. All right, so this is telling you where it all is. It could also give you a reference, like to go either get it through a web interface, if you want to get it off that machine, or it's just going to say file, right? It's giving you an href saying, hey, it's a file, it's on the C drive, tells you where it's at. Basically, it's telling you what's on that machine. So maybe you have a DNC system, you want to query the machines and say, what files do you have there? Or maybe you want to say what tools are on that machine, and you want to have an application in the tool room that checks all the machines for their cutting tools and see what their tool life is. Okay, so if I scroll back up the top, I look at any one of these tools. Here's my cutting tool. Has a cutting item. Cutting items count is 1, which means it's one edge. Okay. It's an end mill. It's currently used. It's allocated. It's available and allocated to the machine. And here's the item life. So it's got in minutes. Its limit is 300, and it's currently at 185. So you know what the life of that tool is. So you could have all of a sudden an app that just emails the guy in the tool room and says, you got to go out to machine 12 and get tools 26 out of there because the tool is about to expire, right? You need a replacement. And you could be proactive about getting people to fix tools before they expire. Pretty cool solution if you want to create something like that. This is assets. There's ways of querying assets. Do a probe command. In the probe, you're going to get back information about the assets buffer, telling you how big the buffer is, okay? I believe it's also going to tell you some other stuff. Hang on. Probe command. Talk about this agent in a second. Device items doesn't show the asset. I thought it was going to show an asset count up here, how many of each type, but it doesn't. But it does tell you asset count 230. Okay. So if I only want to see cutting tools, this is not XPath. It's basically MTConnect path. Okay. For assets, it's very unique. We just say assets type equals cutting tool, and it's only going to return cutting tools. Maybe if that's all you want to do and you have an app that's looking at cutting tools, you can do that. If you have a assets of type file, you can do that too. You can just say asset type file, and it'll return that. Okay, so I'm going to do a demo here where I'm going to, again, how do I get this data into the agent? I will say you could use Shutter or HTTP put. It really depends. If I'm writing an adapter and I'm doing a Shutter adapter, I can just do a multi-line. I can actually do it through Shutter. If I want to send it as an HTTP put, I have a tool management software that's pushing data and documents or doing DNC through the agent as custom XML documents. You could do that too. You can use HTTP put. So I've got some sample files. Of course, I'm going to do a repetitive. Here's my asset files. For example, cutting tool. I've got a simple little cutting tool. It's just one cutting tool instance. Okay, and I'm going to use this file to just keep pushing stuff into the agent. Same thing with a file and a QIF sample. So I'm going to start my agent. Agent's running. Okay, just starts up, connects to MQTT broker and my local adapter if that was running. I'm going to do localhost current. I'm going to say assets. Enter. Asset count is 0. There's nothing in my local agent. So what I'm going to do is I'm down here. I can put I'm going to say cutting tools, and it has to have a unique ID. So I'm creating a unique ID every time I send something. I'm going to choose XML. I'm going to go to cutting tool, that one that I showed you. I'm basically going to send the same file multiple times. And I'm going to say send. And now when I come here and I hit refresh, asset count is 1. I'm in the asset buffer. And you see cutting tool, 1 cutting tool. I have this automatically increment to a 2 just to save me some time. I hit send it again. I should get asset count 2. And now I have 2 tools in here. Okay. So of course, there's obviously a way to remove the tool. You can send the tool again and update it, okay, with the same index. And that's beyond the depth that we want to get into in this session. But essentially, you need to know that there is an assets buffer, and it can do cutting tools, material, files, QIF. So I can come in here. I'm going to say I want to do a QIF document wrapper. Go in here and choose QIF, push that. Now when I come in here, it's going to say asset count 3, but I want to have mixed assets. Okay, so here, QIF document wrapper. So I've got an inspection, says it passed, did some real measurements, okay, told me what my touch point of the center of the probe was, what the diameter of the probe was, blah, 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 blah. It's a complete inspection document, okay? But I still have my cutting tools in here. So I have a QIF document, and I have 2 cutting tools. That is assets. Okay, close this. And this is something, I'm going to get into some really interesting stuff here. Querying an agent with multiple devices. We talked about this yesterday. I think somebody brought it up again today about using agents. My recommendation is 1 agent per machine. There is a few slides tomorrow that talk about pros and cons, and you'll see why. But if I were you, I've used 1 agent with multiple machines, I think once, and I swore I'd never do it again. So I'll explain to you why. And I'm also going to explain to you what the name attribute can be used for. So we're going to build a multi-device file real quick, a small one. We're going to load it up, and we're going to query it, and then send data, and show you the do's, don'ts, and the caveats of having that. So get out of here, close everything down. I'm going to go into my demo, agent, device file. I'm going to make this real simple. I'm going to reduce some of this. Yeah. Get rid of some of these. I want this file to be nice and small. Don't need emergency stop. We got controller mode. We got alarm conditions. This is good. Format. Save it. Okay. So as I told you, we can have a device file with multiple devices. Inside that devices header, I can put in 1 or more devices. So I'm going to do this. I'm going to say I have 2 machines, and we'll use Mazak. Right? We have 2 Mazak machines, let's say. They have the same, we're going to make an assumption, they have the same exact adapter. Because they came from the same vendor, the same OEM, it is very likely that that adapter is going to use the same exact IDs, right? So we talked about these IDs, and we said, hey, this is how the agent maps. key value pairs from the streams coming in from the adapters. This is how it maps it to data items. And we also said that these have to be unique. So here's the caveat. I'm going to come in here. I'm going to say, I'm going to copy this device. Say copy. I'm going to go paste. So now I'm going to format it. Format document. It's nice and clean and neat. I got now a second device down here. You notice I'm getting all of these red marks. That's because I can't have duplicate IDs. They all have to be unique. Well, wait a minute, Neil. If both of those adapters are going to be sending data to this agent, they're going to be using the same exact IDs. I got a catch-22 here. The standard says these have to be unique, but yet the adapters are sending the same exact tags. Okay, so first of all, I have to fix this. I got to come in here and I'm going to say this isn't device 1. I'm going to call that device 2. And I'm going to say availability to, controller to, mode to, condition to, path to, blah, blah, blah. They all have to be unique. It doesn't matter. I can make them Neil 1, Neil 2, Neil 3, whatever. So when I go to my device file, and I have this adapter sending information to my first machine, let's say, and I got a second adapter, it's MQT, it's going to send it to my second machine. I can come in here and my name, I got to call this device 2, okay? In my device file, I can come in here and I can do this. I can actually pipe the data in. I can say device equals device 1. And I can say device equals device 2. And this helps filter. This is just step 1. This says, you know what? The data that comes in from this adapter, it's only for device 1. Okay, that's fine. The data from this adapter is only going to be for device 2. Save that. You say, okay, that's great, Neil. But the adapter on machine 1 or device 1 and device 2 is identical. And they're sending avail, mode, execution. Okay, they're sending all of that the same. Machine 1 is going to get its data. Machine 2 won't. Why? Because these are now different. How do I fix that? Okay, so what we can do is we can use, I don't even know if it's documented. This might be a little known caveat of the, or a feature, I should say, of the reference agent. And that is, if it goes through here and it can't find a data item with a tag or ID that matches the key value pair coming in, it's going to go back through and look for a name attribute. Name attribute is optional. I can come in here, for example, on availability, and I can say name equals, tells me if machine on, okay? It could be anything. It's an extra layer. Like we have types, subtypes, like so position, subtype absolute or actual, name, you could give it something. Okay, so in other words, a third layer of description. It helps you add more context if it's something user specific or user unique. But it also, for availability, I could come in here and I could put avail, okay, which is the tag that comes in, key value pair that comes in from the adapter. It's going to come in here, it's going to say the MQTT data, it's got to go to device number 2, so it's going to put it down here in this second machine. And it's going to look for the ID. If it doesn't find it, it's going to look for the name attribute, see if there's a name attribute that matches. Okay, so I'm going to come in here and I'm going to do controller mode. Okay, I'm going to say name equals mode. I won't worry about that one. I'll just use a few of these. Execution name equals execution. Trying not to forget to tell you about something else here. Name equals execution. Okay, so now I'm going to save this. I got no whammies. I don't see any red marks. I'm going to save this. I'm going to start my agent. With any luck, I'm not going to get any whammies from any errors from the agent. It should start up clean. And it crashed. Oh, the device UUID has got to be different. It's fine. I'll change this to 6, 7, something silly. Save it. Run it again. And knock on wood, everything starts up. Okay. So I'm going to open up my browser, go to localhost, it's doing a current, and I'm going to open up my adapter. My agent's going to connect to my adapter, and I'm going to say execution, vertical pipe, and I'm going to say active. First machine is active. Come in here, I'm going to hit refresh. Oop. Refresh. Execution. Type it. Oh, that was correct. And not restart. Maybe that was it. I just did this demo. Agent's running. Fresh localhost. I'm not getting my execution. So I did save that. Maybe let's take this out. Maybe that's I usually don't use that because I don't have 2 machines. Let's see if that works. Agent running. Active. Come in here and refresh. There it is, active. So it has to do with the device specific. But anyways, so he said I sent in execution. And I got active. Okay. Down here, the second adapter is going to send execution. It's not going to get in there, right? I send execution. Now it found the first one and named it. If I want to send something in on the other adapter, I remove it from both. I could send execution 2, obviously, and it will get it. But if I send execution to or something unique, let's do that. It's not set it to execution. Yeah. So I'm going to send it in this way. It's going to call me a liar, and I just did it. Let's connect. Send it again. I go refresh. You're going to see the same one change, right? Yeah, so send the same one change. So what it's doing is it's finding the first device in the device file, which is device 1, and it's finding execution, the first one, and it's putting it in there. So that should have, I might have had a typo in here. Device equals, yes. Device 1, device 2. That should be, this should work. Don't know why that didn't. Start my agent. Try sending that again. Refresh the browser. And with any luck, there you have it, ready. So I had a typo in there. So device 2 is now getting that. And if you look at the command I sent execution. I didn't send execution 2, I sent execution. So what did it do? You see up here, this device 1 is still unavailable. It basically, the agent said, okay, all the data coming in from the MQTT adapter goes to device 2, and I sent an execution tag. Well, it didn't find an execution ID, right, because this is set to execution 2 to be unique. So it went through again, it says, find me a name, see if the name matches. So it's kind of doing it didn't find what it was supposed to find. Let's see if they have a name, and let's assume that that matches. Why am I telling you this? Is because some vendors actually do this. You have an agent, and they put name attributes in all of them, and they'll do like D1, D2, D3 for all the IDs, and they don't even use the IDs. They don't send any data to the IDs. They make all the names the key value pair, and they're basically mapping to name all the time, which takes away your ability to use it as like an extended tag, extended attribute, or a context to add context to your data item. So I always strip names. I take them out. I don't use them unless I want to provide additional context. You should always be using data item ID. That's what the agent maps to. You only need it is if you have multiple devices in a file and you're sending data from the same adapter type. Obviously, the IDs have to be unique. Okay, so that's something to keep in mind. Something else I want to talk about, and I'm going to open up a different device file for this. Sample device files. This is a basic CNC. Let's see if it has access data in there. Nope. CNC level 1 machine. Yes. Okay. So here I am. I'm looking at a machine tool. Has components. You see it has axes. This is the first time you see axes. So the rule for components is every component has to have a name. Right? We talked about that. Data items don't have to have a name. It's optional. But components have to have a name. And for components, they can be whatever you want, except in the case of axes. Specifically, not the component axes, but each linear or rotary axis. You have an axis ID, has to be unique. It could be NEIL1, NEIL2, NEIL3, it doesn't matter. Okay. The name is very specific. And if you're a machinist or you're in industry, you know what the right-hand rule is. You know what Cartesian coordinate systems are. You have X, Y, and Z, A, B, and C. So if you have a rotary axis that's rotating around the Z axis, the name has to be C. If you have a second one, it's going to be C2. It's going to be C3. Okay, so I have C or C1. It doesn't matter. Okay, using C by itself is maybe bad. You should always use C1. Right? It's better to do that. So you have C1, you have C2, C3, and so on. So basically, I have a rotary axis around X, Y, and Z. But you'll hear complaints from OEMs or something. They say, or end users, they say, well, that's not the name of my axis. My axis is called W or V. Okay, and it's like, that's fine. You can put a native name here, and you can say what the actual name is. You can say the name is, Jabberwocky for all I care. It doesn't matter what the OEM calls it. You can say native name equals whatever, and it's freeform text. But the name attribute, when you go to validate one of these files, this name attribute will fail if you say C-axis or something like that. It will fail validation. That's incorrect. So X1, X2, X3, Y1, Y2, Y3, C1, C2, C3, and A, B, or C for rotary axis depends on which axis it's rotating around, which linear axis it's rotating around. So that's, make sure you remember the right-hand rule, look it up. C rotates around the Z axis. So name attributes on components is mandatory. On rotary linear axes, you have to give a name, and it should be X, XYZ, ABC, 1, 2, 3, 4, whatever, how many there are of each. So X1, X2, X3. Okay. But you'll notice every single controller, every single component has a name on it. And that can be freeform text. You can call it what you want. Path, path 1, Neil's path 1, whatever you want to call it, doesn't matter. Data items, everything has an ID, including components. Okay. So path has an ID, data items have an ID. Name is optional on data items. You don't need them unless you need to have multiple devices in a file. for mapping, and or if you don't, if you only have one machine in a device file, you can use them for extra context. Okay, we're coming up on time, and that is the end of my presentation. So if we have any questions, Mike, that you've seen or something that maybe if somebody wants a quick explanation of something, we can do that.
Yeah, let's take a look and see what we've got in the list here. Most of the questions have been answered. Anybody's got any questions that weren't answered, please drop them in the chat right now, and that way we can have Neil address them rather than me trying to search.
I see one right there, Mike, and I totally forgot to do this.
Go ahead.
So talking about querying by device. So the answer is yes. Okay, is my agent still running? Yes. So if I go here and I say, look at my query, this is something I did not do. Localhost 5000. When you do a current command or a sample command, you're getting everything in the buffer. And that's one of the downsides of having multiple files in here is that they're sharing the same buffer, which means it goes through the buffer much faster, right? But what if I only want the one machine? Specify it in the query. Device one. Not current / device one, but it's current. I got one device or two devices here. Device stream. Yeah, two devices. Should be right. There we go. I don't know what I was missing. So you put in the device name in your query after your port. You put in device 2, current, sample, whatever. XPath after that, right? You can do whatever you want from, and it will only give you information about that device. So if you have 10 machines defined in that one agent, you can query each individual machine independently and just get back that data. But keep in mind, they are sharing the same buffer. All that data is going into that buffer. Great question. Thanks, I missed that.
So one little recap, Neil, just to kind of circle back the wagons here a little bit, is the discussion about, you said one adapter, one agent, or I agree with that. My experience and what we've run into is if you have a fairly new CNC machine from a quality builder where they're providing a decent adapter and agent, and I'm going to use Mazak as an example, their latest machines, again, it depends on, and Neil, jump in on this because I know you were the architect on some of these. Take Mazak, for instance. I've got a customer here in Chicago that's got 20, 30 Mazaks. They've got MTConnect on almost all of them. And the oldest machine is an old M5 with a Fusion 640T controller from what, Neil, like the late 90s on that one?
Yeah.
And it's got Windows 95 on it, and it just doesn't have the horsepower to give, MTConnect 2.6 out of it. So we're getting 1.3 or 1.4 out of it, whatever was available from that Mazak was providing. That one, we've got the adapter on the machine and the agent on the server to take the load off the CPU, so that we're using a Mazak internal protocol to get the data from the adapter to the agent, and then we move up a little bit in technology to a later machine where we've got adapter and agent all on the CNC control because it's a fairly modern CNC with Windows on it. We can install the agent on there and have it all running. That's the ideal condition because my application only has to query an IP address with port 5000. And then we've got another hybrid where the machine was a later model, but had a Linux-based controller on it, and therefore it couldn't run the Windows-based agent. So in that case, I've got adapter and agent running on the server, communicating with that machine over a different protocol. Can you give us a little background on the different methodologies that you had to use to support all that different eras of equipment?
Yeah, so I mean, in order to do that, number one, older equipment, if it didn't have the overhead or it wasn't allowing me to run the new agents, which I believe 95, it wouldn't run on 95. No. We just put an adapter on there, right? And right. The adapter was literally running old code, run compiled with like Visual Studio 2010 or something like that, you know, C++ code or whatever, and
Right.
you compile it for, you know, Windows 95. I will tell you this today. I don't care if the machines come in with adapters and agents or not. I use my own agents. And here's why. I put agents on the servers, okay, or in the cloud, whatever you want to do, but you have complete control over the agent and the configuration of it, and you just point it to the adapter on the machine.
Okay.
The reason for that is twofold. One, you have a new agent that doesn't have any bugs, maybe, right? It has things fixed. Two, you got new features in the agents. The agents allowed, all the new ones do JSON, MQTT now, right? You can do all this extra stuff. So if you want to add sensors to a system, well, the 1.2 or 1.3 agent isn't going to let you do MQTT to it, right? You know, so you use the latest and greatest agent on a server, and now you're grabbing data from different sources for that one machine. The other thing I like is probably the third thing is version control, schema control. I have multiple machine adapters on equipment that are 1.2 and 1.3, and I'm serving up 2.5 data. I've got my schema set to 2.5. And here's how you do that. If I go into my config file, my agent config, and agent, and I go to my agent config. This is something, I don't know if we touched on it a little bit, maybe we'll just reiterate. Schema version 2.5. I'm going to comment this out. Okay, hit save. I'm going to stop my agent. I'm going to start my agent up again. My agent's running. And we said when we do a local host, right, we do a refresh, look, 2.5. It's telling me that the data that I'm serving up is 2.5. Why? Because I didn't specify it in the agent config. So it's going to say, oh, I'm a 2.5 agent. And if you look on the header, you see this version right here. This is the version of the agent itself, the executable, 2.5.11. That's the latest 2.5 version that there is. So it's a 2.5 agent. It's going to default to 2.5. Well, what if I have an adapter that's 2.0? Okay, so I can stop my agent, go to my config file. I can set this to 2.0. Okay, I'm overriding the agent's default to give it 2.5. And I'm going to start my agent up again. It's running on the other screen. I hit refresh, 2.0. Okay, so I'm telling the client I'm serving up 2.0 data right now. The agent version is 2.5. Why? I want to have MQTT. I want to have all the latest and greatest features that the agent has. So I'm running the latest agent. Why? It's going to be compatible with all my systems. If I'm using JSON, right, I got to make sure I'm using a late enough agent to run all this JSON stuff out of there. So even if a vendor provides a machine that has an adapter and an agent, I don't even use the agent. I go straight to the adapter. I may look at their device file, copy it, and modify it. But here's what I might do. Remember the Ruby script. I have 1.2 adapter or 1.1 adapter on a machine. It's so old and they won't update it that I have to convert it to a new, fix the execution state because they had a typo. Yeah, I just fixed it. Now it's 2.5 compliant, right? It may not give me all the different variations of the new execution, all the other enums, right? But it doesn't give me anything that's going to generate a validation error for 2.5. So I can have 1.5, 1.8, 2.7, 2 point whatever adapters sending me data, and I can override the schema version to whatever I want, and I can always use the latest and greatest agent for the latest and greatest features. So I could go back in here and I could set this to 1.8 if I wanted to, right? And it would say, hey, I'm serving up 1.8. When you validate it with validation tools, if you have an agent that's newer than it and it's sending information that doesn't exist in 1.8, you will get a validation error though. So can you, I don't want to use the word trick. I really hate to use the word trick. Can I accommodate an old adapter and kind of update it and say, all right, you only give me 10 tags, but they're 2.5 compliant. So I'm going to say, yeah, I'm serving up 2.5 and I'm going to ingest from an MQTT source, 2.5 tags, and I'm serving up the latest and greatest data for an old machine.
So that's a great segue into tomorrow's sessions. The first session in the morning tomorrow, we're going to review latest and greatest features of MTConnect, and we're going to also go through the progression from the beginning 1.0 all the way up to the latest 2.6, and maybe even a little bit on what's coming out in 2.7, to give you an idea of where we added certain data items and certain functions into the standard. That's part of what the MTConnect.org and the standards committee and the executive committee do, is us and our working groups help to add new features that customers are asking for, and then we get them validated, we vote on them, they're approved by the committee, and then they get published into the next level of the standard. So that'll be a great segue tomorrow. This is also a very interesting point, is to make sure that if you're just getting a bunch of adapters and agents from a wide variety of builders, in Neil's comments, the best way to do this is to have a consistent standard agent that you're using across the board, so you're getting the latest and greatest features of the agent. But you can certainly do that with older adapters, and that's a very important part of the standard of what we can and can't do here. So that was great to touch on that.
Yep, you can always trick it.
Yep. The other question I have for you, just one from my own experience, what's your best approach? So if I get an adapter and agent or an adapter from a vendor, and I can do a probe and get the data that the adapter is giving to the agent, is that any different than me looking at the raw shutter data coming out of it to see what tags are in the raw shutter data?
No, because, for example, if I come here and I'm doing this, I know the data item right there is mode, condition, right? I know those. The agent actually has a feature that you can go and it will read this XML file and basically redo it at the next agent level, right? So you can have an agent reading an agent. So that is possible. I don't know if anybody's doing it or not. You could actually write, I know somebody who wrote a Python script that read this and basically scraped this all out and turned this data into an adapter data, right? So you could say, hey, I'm outputting execution with this value, whatever value is coming out, and you're ignoring the rest of it. Maybe you're sending the timestamp too, but now you have a new agent with a new device file, and you're giving it, calling it execution as well. But there might be things in here that you're changing the units, or you're fixing it, maybe even, I don't know. But you could certainly scrape this and make a Python adapter reading this XML document for sure.
Okay, great. Any other questions? Let's see here. Let's take a look at.
Somebody asked about the shutter document. The shutter document, for some reason, I thought it might have been on the MTC Cup site, but it maybe not. I know that it's on the project's website. So if you're a member and you get access to the project's website, you can go in there and you can find a lot of documentation, white papers and stuff. I can certainly send it to you if you send an email. That's fine. We can send that to you.
Ted had one comment. He uses Haas NGC controllers, which, if you're not familiar with Haas, the NGC stands for Next Generation Controller. That controller came out in about 2014, 2015, and is pretty much the standard on most new Haas machines today. Prior to that, they had a different architecture. The big thing that NGC gave us was it made Ethernet standard, and it also had their own version of MTConnect. We kind of internally call it Haas Connect because it didn't exactly follow the standard. That's another great one that you can take the data coming out of those controllers and then do your massaging that we've talked about in these sessions and get clean MTConnect data coming from it. Ted's comment was that adapters creates a ton of data over shutter. Many of those data items are not in the device model and therefore are not represented at the agent level. So how would you deal with that, Neil?
If you know what those are and you can figure out what they are, all you got to do is go into your device file and add new data items, right? The issue might be if it's just an analog value, it's a sample reading, easy peasy, right? It's a pressure, it's a whatever. If it's an event, if it's state information, the issue is it doesn't map directly to, our states. So what you can do is say, if this tag coming out has this value, running, like I saw some tags that came out and it said, what's the X state, like, running state or something. It says in cycle. Well, in cycle doesn't exist in MTConnect, active
right.
does, right?
Yeah.
So you could map it. You could use a Ruby script to transform it. Or you can derive state. And that's something I've only had to do like once or twice. And that is you read three different signals, like either they're Booleans, like bits or something coming out of the PLC or out of their tags. You read three of them, and you can do that in Ruby as well. And you can say, if this and this and that is all one, then execution equals active, right? So you can definitely do that in the Ruby script as well. Done that.
Yeah, Trey just commented that some OEMs report execution as integers with no clear distinction on what each value means. That's another problem that we've seen as well.
Validation failure. Yep.
Yep.
And the thing is it might be more painful to go ask them to try and fix it, or they may have already told you no. That's fine. If you can figure out what they are just by doing user acceptance testing, standing at the machine, you say, okay, a 1 is in cycle, a 2 is stopped, a 3 is feed hold, right? You can map those. You can use a Ruby script and fix it. And now it's like, hey, don't worry about it. I got it. And you fix it.
Yeah, and that's the issue. Whether you're doing this yourself as an end user, consumer, with your own IT people or your own programmers, versus having an integrator work with you to help clean those things up. That's what we do as an integration company, is to help provide. You don't have to worry about the data. We're going to clean it up and make sure that you get the correct data showing up on your dashboards or however you're using your end results. And don't see anything else. Neil, do you see anything else other there in the last few that haven't been addressed already?
Nope.
Certainly,
if you have any questions, we're going to make sure that we have a someplace advertised. We'll probably send an email out with a bunch more information about contact information, how you can get a hold of and get answers to stuff that you want. So
yeah, this is our first go round for doing this through the MTConnect organization. So we're learning on some of the stuff. We will have follow-up information for everyone. So pay attention to your email. Like I said, it will go out to whatever email you used to register for your sessions. You should be getting an email after each session if you haven't already. If you registered for a session, then the email is coming from AMT with links to the information and to download the raw video. We will be cleaning those are through the emails. We will be cleaning those videos up and then placing them probably on the MTConnect YouTube channel with a little bit cleaner. We'll take out some of the bantering and things that we've done, and then also give you, we're also planning on trying to put chapter flags in it so that you can actually jump right to a chapter in the video and not, as I said earlier, not have to watch 2 hours of video to find the piece of information that you wanted. Also, we're planning on taking these presentations, PDFing them, and make them available to you as well. We need some time to get that done, so keep looking at your email for the next week or so. We've got a great session tomorrow. The morning, again, like I said, is going to be focusing on what's new in MTConnect, and then also 2.0 to 2.6 in the future that we're going on to. And then the afternoon session, Trey will be back talking about validation and what he and his company have been doing with their validator. It's a cool product where you can literally run it against all your machines, and it will come back and tell you whether you're following the rules or not. This is one way that we need to provide some tools to the end users to basically keep their OEMs accountable and make sure that their vendors that they may be paying for adapters and agents are actually following the standard, so you can trust the data that you're getting. So tomorrow will be our wrap-up day and should have some very good discussions going on. Thank you, everyone, for coming today, and I look forward to seeing you guys tomorrow. And thanks, Neil, for another 2 very great presentations today. Learned a lot, I think.
Yes, sir. Have a good one, everyone.
All right, guys. Take care.